there for you 24/7, 365. Sorry, that's not really good enough. If your friend truly had your back, they would be there for you 24/000067365.2421891. Also, George Washington was born on February 22nd, 1732. At least, that's what we're told. However, his family Bible says he was born on February 11th, 1731/2. So, which is it, Mr. I cannot tell a lie? Oh, and don't even ask about 1752. In Russia, 1752 looked pretty normal, but check out what the British Empire was up to that year. Nothing really out of the ordinary, except Ember. The second was followed by the 14th. Were 11 days just deleted? Where'd they go? What happened then? It is time to question time and how the Earth moves. Reconciling both of these things has led to some pretty strange things. We all love time-lapse videos of the stars moving across the sky. But really, we are the ones who are moving, tumbling through the universe on a giant, wet rock vehicle called Earth with a windshield called the sky. As viewed from above the North Pole, we spin counterclockwise. West chases east. I always remember this by thinking of the US as a weird, mane-headed animal with Texas and Florida legs running forward. But we don't just spin. We also revolve around the sun on a plane tilted 23.4 degrees relative to our spin. It's kind of nauseating at this scale. But from this perspective, you can see that the sun rising and setting is just the Earth pointing you towards and then away from the sun. This motion causes your sunrise, your noon, the moment when the sun is highest in your sky, before your sunset. To more closely investigate this movement, let's talk about meridians. You are on one at this very moment. Your meridian is just a line from where you are right now, straight toward and south poles. It's a line of longitude, as opposed to the horizontal lines that lay flat when north or south is up that we call flatitude. Or actually, latitude. The sun is highest in the sky to you, your noon, when your meridian is pointed right at the sun. A cool thing happens at this moment. All shadows around you point directly towards one of Earth's poles, unless you're on the sub-solar point. On the subsolar point, shadows fall straight down so they can easily disappear. Twice a year, the subsolar point crosses over Hawaii, the only place in the US where it hits land. And when it does, it is called Lahaina Noon, meaning cruel sun. Straight vertical objects look unnatural during this brief time, like they don't belong, as if they were photoshopped in without regard for reality. In Honolulu, a sculpture by Isamu Noguchi called Skygate casts a twisted shadow all day, every day, except during Lahaina Noon, when its shadow is a perfect circle. You may not live in a place where the sun ever appears directly overhead, but once every Earth rotation, the subsolar point falls somewhere on your meridian, making it noon for you. The technical name for this noon for you is local apparent solar noon. The clock on your wrist and the clock on your phone don't tell you your local apparent solar time, because long ago we realized that if every meridian had its own time, a person just a few kilometers away, seeing different shadows than you did, would disagree with you on what time it was. So towns adopted their own time. Now later on, this trick was standardized and time zones as we know them today came about. But that's not all we didn't like about shadow-based sundial time. To explore deeper, we have to begin by asking, what's a day? I mean, obviously it's just the time it takes the Earth to turn around once, right? But according to what? Everything else in space is moving in some way too. The universe doesn't include a convenient sheet of graph paper at absolute rest we can trace paths on. The best we can do on that front is to look at very, very far, far, far away stars. So far away, like distant features of the landscape out the window of a moving car, they barely move as Earth does. To them, a meridian on Earth completes a trip around about once every 23.9 hours. This is called a sidereal day. Sidereal means pertaining to the stars. Even though the sidereal day seems pretty clear, it's not what our calendars and clocks are based on, because there's a nearer star whose position relative to us has a bigger effect on our lives: the sun. Looking down on the North Pole at Earth's counterclockwise spin, the Earth also moves counterclockwise around the sun. After a sidereal day, the Earth has moved a bit along its orbit, so some more rotation is required for the same meridian to point back towards the sun again. This longer definition of one rotation is what the modern calendar and clock is based on. It is called the solar day. But here's the thing. Exactly how long the Earth has to rotate to complete a solar day changes day to day. Our clocks are just based on the average amount of time this takes, so throughout the year, they fall ahead and behind the sun. This is a solograph, a picture of the sun's path across the sky every single day. If our clocks actually told us local apparent solar time, if you took a picture of the sky every day at noon, you should get a line of suns. But this is what really happens. Over the course of a year, it will appear as though your clock is running slow, and then fast, and then slow again, and then fast again. This problem was known since at least ancient times, even if its cause wasn't. In order to reconcile the two, the equation of time was constructed. In this sense, equation means to reconcile. The equation of time was applied to what a clock said in order to compute the real time, the solar time a sundial would show. Now, some fancy clocks, called equation clocks, were made that would do this for you, but eventually, we gave up. We gave up and just said, no, the real time isn't what the sun says, it's what our inventions say. Now, this transition was a big one. It was humanity growing up. It was like the first time you realize you're stronger than your parents. We realized our timepieces were more regular and turned our backs on the timepieces nature had. But what causes this disagreement in the first place? As it turns out, the answer revolves around revolving, the way the Earth revolves around the sun. If the equator faced the sun all the time and the Earth always orbited at the same speed, the subsolar point would just stay right there on the equator throughout the year, and the amount of extra time spent rotating the Earth needed to do to finish a solar day would always be the same. But those two things aren't the case. First of all, the Earth's orbit is slightly elliptical, so its speed varies throughout the year. When it's moving around the sun faster around the beginning of January, the amount of extra turning time needed to complete the solar day is longer than when it's further away from the sun and moving more slowly. There's more. Because the Earth is tilted, the subsolar point is dragged throughout the year in a circle around Earth that's not the equator, so it changes direction, moving northeast, then leveling out and going southeast, before leveling out and going northeast again. During times of the year when the subsolar point is being dragged by Earth's orbit mostly east, it gains against Earth's spin faster. More time is required for the day to finish. Now, by coincidence, we are alive at a time when both of these phenomena lengthen and shorten days at roughly the same time. So they add up, making September 18th almost a minute shorter than the longest day of the year, December 22nd. For Northern Hemispherians, December has the shortest periods of daylight, but the whole solar day, from sunrise to sunrise, is for everyone on Earth the longest of the year on December 22nd. People in the north just spend most of it in darkness. Earth's tilt, it doesn't just affect how long a day is, it also affects how long a year is. This is because the Earth's tilt is what causes the seasons. For the half of the Earth tilted towards the sun, the same amount of solar radiation is spread across less space than it is on the other half, so there's more heat energy laid down per area. This causes what we call summer and winter for the other half. The amount of time from one of these seasonal orientations of the Earth to its occurrence again is called a solar year, or a tropical year. It's a very useful way to define a year because it contains every single season exactly, since it's based on the very orientations that cause them. But the problem is this: the number of solar days that occur in a solar year is not a whole number. It's almost 365. But after that many solar days, about a quarter of a day more happens before the solar year starts again. This makes designing a calendar more like designing a calendar. If your calendar only ever has 365 days in a year, over time, those dates will drift from the seasonal positions they used to occur during. Unless, this extra quarter of a turn adds up to a full day after 4 years. See, March 1st is coming a day too soon now, so if we just delay March by adding an extra day at the end of February every 4 years, a leap day, we're back on track. Leap days do not add days to your life. You're still going to live the same number of them. They just change what we call them. But really, who cares about being 1 day earlier every 4 years? I mean, 1 day isn't much, you'd hardly notice it. But over time, well, if America's founders had declared not only independence from Britain, but also from leap days, and abolished them from happening, today, 240 years later, their calendar would be a full 2 months ahead of Earth's position, putting America's coldest winter days in April and its hottest summer days in October. Adding a day every 4 years is what the famous Julian calendar does. Introduced in 46 BC by Julius Caesar, it was the de facto standardized Western calendar for a very long time, more than a millennium. But it's not perfect. Look closely. Leap days actually move the calendar just slightly too far each time. because I lied. 365¼ solar days don't occur within one solar year. The real number is slightly less and fluctuates year to year based on long-term changes to Earth and the Sun's movements, which means adding one day every 4 years is just a teensy-weensy too many. By 1582, Julian calendar dates were 10 days behind the seasons compared to where they used to be. Now, that's not bad, 10 days in more than a millennium and a half. But the Catholic Church cared because they wanted Easter to occur exactly when it used to centuries ago. Astronomers at the time realized that if leap days pushed the calendar too far behind the seasons, we would just need to celebrate fewer of them to fix the problem. Specifically, we would need 3 fewer leap days every 4 centuries. The rule they wrote to achieve this stated that every 4 years would continue to be a leap year, except if it was divisible by 100, unless it was also evenly divisible by 400. This removes 3 every 400 years. On October 4th, Pope Gregory XIII introduced this new calendar. It took his name, the Gregorian calendar. He also undid the drift that had occurred since the early days of the Julian and declared on October 4th that tomorrow would be October 15th. October 5th to the 14th never happened in 1582 in countries that listened to the Pope. It took the rest of the world centuries to hop on board. England and its colonies, like the soon-to-be United States of America, adopted the Gregorian in September of 1752, by which point their Julian dates were off from the seasons by 11 days, hence the disappearing of the 3rd through 13th. When adopted, the first of the year was also moved from March to January 1st. This explains why George Washington's birthday has 2 answers. As a caveat, keep in mind that Earth's oceans and liquid insides and other celestial bodies are always pulling and tugging and sloshing around, minutely changing Earth's movements. Their effect is measurable, but difficult to notice at big scales and also don't look like much in the short term. Short like the length of a human life. Looking from above the North Pole, the equator spins counterclockwise at about 1670 kilometers per hour. Relative to the sun, Earth orbits counterclockwise at 108,000 kilometers per hour, along a path tilted 23.4 degrees to its spin. Within our local neighborhood of stars, our entire solar system is drifting 70,000 kilometers per hour, roughly in the direction of the bright star Vega in the constellation of Lyra. And our solar system is part of a giant galaxy called the Milky Way. On a plane tilted about 60 degrees, approximately like the windshield of a car, looking from above Earth's North Pole, our entire solar system races clockwise around the galactic center at about 792,000 kilometers per hour. Our whole galaxy is also moving through the universe. We know this because when the universe was very young, it was so hot, electrons and protons jumped around and photons of light scattered constantly. They couldn't travel very far before scattering again, so the universe was opaque. But then, around 380,000 years after the Big Bang, the universe cooled just enough for electrons and protons to form hydrogen. Suddenly, abruptly, photons decoupled from this obstacle course and could travel relatively unencumbered. The universe became transparent to light. And since that moment, those early photons have been propagating through space. Every day, ancient photons that last scattered off this opaque fog at the moment of decoupling, a light day further from where Earth currently is, reach us. They are part of the cosmic microwave background radiation. It is visible in every direction. Microwave because although they used to be more energetic, the universe's expansion has redshifted them. Now, some parts of this radiation are more redshifted than others because of our own movement through the universe. Controlling for the movements we've already talked about, relative to this infinite, cooling baby picture of the universe, the first and oldest detectable light, we are headed, riding along in the Milky Way, in the direction that the constellations of Leo and Virgo are to us, at a speed of 2.1 million kilometers per hour, towards a thing we don't fully understand yet, simply called the Great Attractor. This is how you, on Earth's surface, are moving through the universe aboard spaceship Earth. Okay, now stop. This is roughly 100 years of Earth's movement through space. This path we've traced, from where we began here, is the path you will take through the universe in your lifetime. You didn't buy a ticket for this ride. Your parents signed you up without asking. But nonetheless, it is quite literally the ride of your life.
Found a safe place for us to spend the night at Lake Geneva. Are you uploading it?
To Roosevelt, all of it. Just in case we're gonna be fine, Mary.
Did you see his face? He's never gonna understand.
Mary, we've been through this. Our life as we know it is over. We're gonna spend every day from now on looking over our shoulders, never feeling safe. We can't do that to him.
He's just a little boy.
I know. It's gonna be okay. It's gonna be all right.
No rest for the weary, huh?
No, I'm afraid not.
Occupational hazard, I guess. Where's it you're working at?
Just planning ahead. Do you think I could speak with the pilot?
Something you need? Perhaps I could help.
I'd just like to radio ahead and make sure everything's in order for when we land.
I think we both know that's not an option, Dr. Parker. They say you're a genius.
Richard!
Not if you thought you could escape.
Richard!
Okay? Okay? It's gonna make you safe. He's done. He's done. You breathing now? Mare?
Hey, Roosevelt.
What? Back up. It's back. Okay. Hey. We're gonna be all right, okay? You stay with me.
Reporting live from New York 1 Chopper. An Oscorp truck carrying plutonium has been hijacked. A police chase is in progress.
All right, let's get to work.
Men, and especially women, possess various organs that are optimally suited for the creation of another human being. The ovary possesses about 500,000 eggs embedded in follicles. Several follicles, and therefore eggs, mature in each cycle. The dominant follicle grows to about 2 centimeters, and the fimbriated end of the fallopian tube, which eventually catches the egg, moves to the site of ovulation. The egg consists of an outer layer called the corona radiata. Underneath is another protective layer, the zona pellucida. Both layers must be penetrated by the sperm cell in order to reach the cell nucleus that contains 23 different chromosomes.
This is another shocker du jour. This is the Jupiter Great Red Spot, and this was taken July 8th, 1979, on a flyby of this particular spot. And they took extremely high resolution image, as you can see. Now, there's a story behind this red spot that Velikovsky illuminated years ago, and I think it may have some validity. I think most everybody's familiar with the giant red spot on Jupiter. It's the Earth fits into that little tiny spot right about there. That's about the size of the Earth and Venus. Now, it's spinning this way. As we can see, the clouds are rippling off of the spot. Now, what is that spot made of? Is it a bulge? Is it a hole? What's going on there? Why are we having this storm there for 350 years at least, they say, and maybe more than that? And this is the giant red spot. Let's examine it closely. Okay, I am going to get into some anatomical discussion about female anatomy. I just put this up here to cover it for a second. So if you're going to be adverse to that, or you have kids, or you don't want to see this, this is nothing more than the red spot on Mars. I mean on Jupiter. But I believe it's also a vagina. I'm just telling you that right now. The ancient texts say the feared god Jupiter gave birth to Venus, which is what caused our catastrophe on Earth. And this, I believe, is exactly where it came from. And that, my friends, is about as close to a vagina as you can get. Now, this would be the bottom towards the anal area, and this is the vagina. And, you know, as far as I'm concerned, this is what happened. This is what was recorded. And Venus spins backwards. Now let me tell you why that's going to happen from this type of a birth on a rotating planet, which is Jupiter, in the right-hand rotation, that's the standard. Everybody spins to the right, every single one of us, except Venus. And the reason is it rolled off of Jupiter backwards. Let me describe that to you. But, you know, let me just show you what the anatomical version of the vagina looks like. I mean, it's hard to not understand what you're seeing there. Now, this is an anatomical version of female anatomy. And when I was looking at the clouds, Jupiter spins like this. And the clouds ripple off of this area. And I realized, I said, it has to be a mound that's forcing it to spin past it, or it has to be a depression where it's being sucked down in and spinning over that way. It happens to be both. This would be a mound and a depression at the same time, and we can see that in that very, very good close-up.
Each chromosome contains DNA. DNA is the blueprint for building our body cells. Eye color, body size, arrangement and function of our organs. It's all in there. If two identical chromosomes occur in one cell, we can later speak of trisomy. The egg cell is transported inside the fallopian tube with the help of cilia and mucus produced by glands in the walls of the fallopian tube. Additional contractions of the muscle layers help to transport the ovum. At a speed of about 3 to 4 millimeters per minute, something else makes its way from the other side of the fallopian tube. Sperm cells, thousands of them, and barely visible. They all have only one goal: reaching the ovum. A sperm cell's nucleus contains the male's genetic information. Through messenger substances emitted by the egg cell, the remaining sperm cells find their way to the ovum. The goal of all sperm cells is to penetrate the two outer layers to reach the chromosomes. The sperm cell penetrates corona radiata and zona pellucida, resulting in the degradation of the acrosome cap. Upon entering the cytoplasm, fertilization occurs, resulting in activation. Activation causes, among other things, a structural change of the zona pellucida so that no further sperm can penetrate. In addition, activation causes the ovum to complete its second maturation division. In this process, the sister chromatids are pulled into opposite poles, and a female pronucleus and a polar body are formed. The sperm's tail and head gradually degenerate into cytoplasm. The condensed sperm nucleus rapidly increases enormously in size, and the chromatin decondenses. Thus, a male pronucleus is formed with 23 unreplicated chromosomes that possess the genetic information of the father. As the two pronuclei approach, both double their DNA, resulting in replicated chromosomes.
This explosive noise is actually the sound of Juno entering into Jupiter's magnetic field, which protects the planet from solar wind. When supersonic solar wind is suddenly slowed down and heated up as it enters into the gas giant's magnetosphere, it produces a bow shock, and this is what Juno detected as it crossed over into this region. NASA then translated Juno's measurements into this incredible audio file that represents the power of Jupiter's immense magnetic field. The gas giant's magnetosphere is considered one of the largest structures in the solar system, extending out to nearly 3 million miles wide. It is almost 15 times wider than the Sun and 20,000 times stronger than Earth's magnetic field.
Alright, so here's how I started to understand this. This is the size of the Earth, which is virtually the same size as Venus. That obviously is the red spot behind it. Now, you see the clouds are coming here sort of straight, and then all of a sudden they do this. That's why I say there has to be a mound or a cavity there, and there really is both. And that is where it starts to swirl, and that is where I started to pick up and understand and look deep into the vagina. And that's what it is. I can't see any other possibility. Now, listen to this. Jupiter spins in the right-hand rule. That means it goes around this way. All right? Now, here's Venus. erupting from the spinning Jupiter. As it came out, it would roll back this way. It would be forced to roll this way, and it would go spinning away in this direction, this way. Well, what is that? That's going this way, backwards. It's supposed to be going the right-hand rule. It's going in the left-hand rule. And it's the only planet that does that. And nobody's ever been able to give an explanation for why that happened. This is it right here. And in the ancient text, it says the feared god Jupiter gave birth to the fiery comet Venus. And at that time, it was a comet turned into a planet as it settled down.
Finally, syngamy occurs, in which the pronuclei dissolve and the chromosomes of male and female are properly aligned in the spindle apparatus. Now, the cell is called a zygote, which is the very first cell of the new human being. The stage of cleavage begins. In this process, the cell continues to divide. 2 cells, then 4, then 8. At a 16-cell to 32-cell stage embryo, we speak of a murula, since the shape resembles a mulberry. The cells are still enclosed by the zona pellucida. Thus, after each cell division, whilst the number of cells increases, the size of each cell diminishes. Finally, the blastocyst is formed. The blastocyst consists of a fluid-filled cavity, the cells of the embryoblast and the trophoblast. The embryoblast is the initial structure of the new human being, whereas the trophoblast is the origin of placenta and membranes. Let's see the individual stages in the fallopian tube. Fertilization occurs at the end of the tube. The first cell division takes place about a day after fertilization. Eventually, further cell divisions happen, forming the murula. And in the uterus, the blastocyst is created. At this stage, the mucous membranes of the uterus or womb has already been prepared for the implantation of the blastocyst. Usually, the blastocyst implants in the posterior wall of the uterus. However, implantation can also occur on the side, as we will see in a moment. The blastocyst floats in the protective and nourishing uterine mucus. For implantation in the uterus, the blastocyst must first hatch from the protective zona pellucida. Then the blastocyst burrows further and further into the uterine lining, like a parasite. Let's take a closer look at this. The endometrium has a protective epithelium and capillaries filled with blood, as well as mucus-producing glands. The trophoblast cells fuse with the endometrium, and a syncytial trophoblast is formed that will nourish the embryo. In addition, hypoblast and epiblast arise from the embryoblast. The embryo burrows further into the endometrium, rapidly increasing in cell mass and leaving a wound, which may result in a completely harmless implantation bleeding. Finally, the amniotic cavity is formed. As the process continues, the yolk sac is created, as well as a non-cellular plug that is later sealed by migrating uterine epithelial cells. The trophoblast rapidly increases in size, with the amniotic cavity and yolk sac remaining relatively small. This gives rise to the chorionic cavity and the body stalk. 3 germ layers form from the primitive streak and node. This process is called gastrulation. The germ layers ectoderm, mesoderm, and endoderm eventually differentiate into various tissues and organs. In the course of the 3rd week of development, neurulation occurs. At that time, the foundation for the central nervous system is laid. The neural groove is formed, closing from the center to the sides. At the sides, small bumps called somites can be seen. The neural groove becomes the neural tube, which later forms, for example, spinal cord and brain. Those cells later become the neural networks, which enable us to think.
Okay, this is extremely interesting. I made a mistake when I said Venus was the only planet that spun backwards. Uranus does a very similar thing, only it's laying like on its side. So instead of spinning down this way, it's spinning or like this way, only backwards. Now, Uranus was one of the primordial gods, and he was mated with Gaia every night until they castrated him, the Titans and so forth. You have to look into this deeply, but this becomes extremely interesting. Uranus has 27 known moons. 27 moons now. Listen to this. Most of the satellites orbiting other planets have names from Greek or Roman mythology. Not Uranus. Uranus moons are unique because they're named for characters in the works of William Shakespeare and Alexander Pope. All of Uranus' inner moons appear to be roughly half water and half rock. The composition of most outer remains unknown, but they are likely captured asteroids. No, they are from a collision of that planet, tipping it on its side, throwing all of this debris out. Look at this. The rings, it has 2 sets of rings in addition to, what is it, 27 moons or whatever, 27 moons, and it's got like 6 rings. They're all dust and size particles, and that's what happens. It's the specific gravity of those particles. The bigger ones will be in closer, and the smaller ones will be out further, that type of thing. And because all of its moons are named now, just recently, they obviously weren't there when they named all the other moons, because all the other moons in the solar system have names that are like Tetchus and Mimas and all of these Iapetus, and they're all of the ancient Greek gods. This is the only one that doesn't have those early names from the Greek mythology and Roman mythology. So I'm saying the collision happened after they had written all the stories of the origin of the universe. And that relates to Jupiter and Venus and all of that stuff. By that time, it must have happened after that, or as a consequence of Venus colliding with the rest of the parts of the solar system. It put the solar system in disruption. It was worlds in collision, exactly as Velikovsky said. And we're going to go deep into his work because he's the only one that really researched any of this. It was all considered insane. And I'm not saying it's not insane. That's absolutely not what I'm saying. I'm saying it is insane, but insanity can also be reality.